and welcome back. In this section, we're talking about some more advanced object-oriented principles. So I've created this sample project here called Advanced OOP, just a small project where we're going to create a few files to explain a couple of these concepts. There are two files in here right now. We've got user.py, and in this file, all we have is a short class that represents a user. So you've got an init method, takes in a username and a password and sort of sets them as the properties of the object you've created. And then it has two other methods. A login method just returns that you've logged in. Potentially this should do something like check a database, compare the password that you've given with the password in the database or something like that. And it's got a repr method. Fairly normal class, you'll create things like these all the time in your project. And then we've got an admin.py class. And this inherits from user. So it takes in all of the methods of the user. And then what we've got is another init method in this admin class, takes in a username, a password, and an access level. And then that calls the user's init and sets the access level property. Potentially this access level could be something like super user or manager or something like that, different levels of admin privilege. Then the repr method here has the admin, username, and the access. And finally, it also includes a toDict method, which returns a dictionary representation of this admin object. So it returns the username as self.username, password as self.password, and access self.access. Just returns a dictionary, and using this dictionary, we could recreate the object. So this is similar to, for example, if you wanted to save this to a database, you would just take each of the properties in this dictionary, you could put them in a database, for example. Now, let's say that we do want to create some sort of database. I'm going to create an in-memory database file, call it database.py, and just code it live in front of you because I think this is an interesting thing to go through. In creating this database, we're then going to use it to explain how multiple inheritance works. So I'm going to create this class database, and the database class is going to have a class variable called content. And a class variable is just a variable that exists within the class as opposed to within the object. So you can access this as database.content, and it'll always give you this dictionary. Then we're going to have a couple of methods, a couple of class methods. Insert, that is going to take in some data and is going to insert it into database.content, users, append data. So again, database.content is this dictionary here, and all we're doing is we're appending to the users list whatever data we received in the insert method. Because this is a class method, we can of course replace database by CLS, since CLS and database are the same thing. Then we're going to have another class method that is going to be remove. And this is going to take in a finder function, and all it's going to do is going to do cls.content users equal user for user in cls.content users, if not finder user. Pretty, standard way of removing something from a list. Do a list comprehension and put all the elements of that list into a new list for as long as they don't match this finder function. So the finder function potentially could be something like lambda x username is not Rolf. So this could be the finder function, and then if it doesn't match that, we will remove it. Finally, just for completeness, and because of course we will need this, let's add a final class method, which is going to be